Hi, I'm Luke from Helix ML, and I'm going to take you through this CI/CD for cloud-native GenAI reference architecture. First, I'm going to show you me using the reference architecture, and then I'm going to show you at the end how to set it up. So what this architecture does is it allows you to set up some workflows where a developer, and you don't need to be an AI engineer to do AI engineering these days, because anyone can be an AI engineer. Anyone who's comfortable pushing things to Git, running tests, and then merging PRs to main. And so what we're going to see here is we're going to be a developer who is working on an AI application. We're going to be iterating on which model we're using, which prompts, any knowledge, and in particular API integrations, and also tests for that. And we're going to iterate on that. We're going to push changes to a branch. We're going to see GitHub Actions testing those changes using this LLM as a judge pattern. This is all built into Helix. And we're going to have Helix test changes to our AI application in this sort of ephemeral namespace, in a test namespace. And then when we've improved the application and we want to actually release our changes, we're then going to merge that pull request to main. And we're then going to see how Flux can pick up the change and via the new Helix Kubernetes operator, automatically deploy that change to production so that users get a better experience. And so that everything is managed using a GitOps approach, where the desired state of the system is always recorded in Git. And that's important because it means that you can easily recover from failures. And what we're doing here is we're making the configuration of the AI application itself, we're making that into a version-controlled YAML file. And so in particular, we're introducing this new AI spec, AI app kind that exists in Kubernetes. And here we're working on this exchange rates application. So yeah, like I said, I'm going to start by actually doing some work with the system. And then at the end, I'll show you how to set up the system from scratch. So the work that I'm doing on the system at the moment is that we are working on this exchange rates application that can tell you exchange rates. So I can show it to you. I can say, for example, what is the current GBP rate? And it goes and makes an API call, and it shows me the GBP rate against a bunch of different currencies. And so in particular, we can see £1 is currently worth $1.29. And so that application, well, I can show it to you here in the app editor. So if we go into the your apps inside Helix and click edit and look at the integrations, then we can see we've integrated with this exchange rates API. And we've done that by putting in this Swagger spec here. But if we go back here, we'll notice we've actually got a failing test on the main branch. So let's go and have a look at that. It's not good when main is failing. So let's go and look at that latest test report. If we go and look at the report, we'll see that we've got a test in here that says that let's look at the test to begin with. We've got a test in here that says when the user says USD GBP, we want the expected output to be just the US dollar to sterling exchange rate. It should mention both your US dollar and GBP and not other currencies. And if it mentions other currencies, then fail the test. So that test is failing. Let's have a look at how it's failing. Well, this is an actual test run that happened as a Helix session, which is like a sort of chat GPT you can run locally. And this USD GBP gives you the base currency, but then it doesn't specifically mention GBP anywhere. So yeah, this is a good failing test. Let's go and debug why the test is failing. So we can see how the system works when it calls APIs is that it will check whether the request is actionable, prepare an API request, and then interpret the response. So let's go and look at where something probably went wrong where it prepared the API request. So that's the original request where the user just said USD GBP. We're kind of looking under the hood. And then internally, there was this LLM call, which was saying, let's construct the API body for this request. And then the user just gave it USD GBP. And let's see, what did it do? Oh, well, the output was that it decided to make the API call by setting the currency to USD GBP. But that's not a currency, that's a currency pair. So what we need to do is we need to teach the LLM how to deal with this kind of input. And we can do that by editing this request prep template that we just saw. And I've never actually tried to do this before, so let's see if it works. We can give the LLM some additional examples, and we can say, if the user asks for a currency pair, like USD GBP, then search for the first, then split it apart into USD and GBP, and search for the second part. Actually, I think US dollar is the base currency, so this will work best if, and search for the non-USD currency. For example, currency is GBP. And then actually when we're parsing the response, well, actually, let's just do it one step at a time. So let's just see if that fixes the the query. So what we can do, even before we've committed this change, we can run the tests. We can do that by running Helix test on the exchange rates app. And at the moment, I'm using the evaluation model of the 70B version because I was finding that was working better. We need to go and set our API key. So I'll do that here. Now it's under my account section. So if I set my API key, then I should be able to run Helix test. And this runs the tests locally before I've even committed anything. And then it loads them up in the browser. Okay, so that's still failing. But let's see. Oh, look, it did actually go and get the GBP rate. So that's good. But then it's still listing all of these other currencies. So what we should do is we should tell it when it responds. So here, that's left over from our Jira integration, that bit. When it responds, if the user presented a currency pair, e.g. USD GBP, and we searched for the non-USD currency, then present only the USD to given currency rate, not including any other currencies other than the two in the currency pair the user provided. So we're just prompting the LLM. And if we run the test again, oh, interesting. So now that's caused our new test to pass. And that's good. But it's caused our previous test to fail. Although the test is working, it says the response does not exactly match the expected output format. So maybe it's a test bug. So let's go and look at that. Interesting. So USD to GBP exchange rate. Let's just say it's concerned that it includes additional information. It's okay if it includes additional information such as the rate being based on the latest data. So let's see if that passes. Yay! Okay, both of the tests are passing. I mean, I think this is definitely an improvement, because now both of these things are giving us correct data. Okay, so I think it's worth doing a commit, but I'm not going to commit straight to the main branch. I'm going to make a new branch, fix failing test, or I'll call it like improve handling of currency pair inputs. So now we're going to push it to GitHub. So what we can see here is that we've got this branch. I'm going to make a pull request because we like pull requests. So we're doing CI/CD for cloud native GenAI. Remember, this entire stack can be run entirely on your own infrastructure on Kubernetes, or even just a simple Docker Compose deployment, including hosting the LLMs yourself on your own GPUs. So let's see, this is the diff. And we made these changes to get the tests to pass by updating the prompting. Okay, great, it passed. Okay, so we got a nice test summary commented by the GitHub Actions bot. Thank you for that. We've got a link to view the full test report, which we go here and we can see it's passing in CI in the same way that it passed when I ran it locally. And then let's go back here. And so we've got a pull request that's open with a green tick next to it. So that's awesome. What's going to happen next is that we're going to merge that pull request to main, and Flux is going to kick in, because Flux is sitting here running in the background. I can probably show you. Yeah, Flux is in the Flux system namespace here. And it's polling GitHub every minute. So as soon as we hit merge pull request, then we're going to deploy that change. Remember, deploying that change is deploying the change into the App Store in here. So at the moment, if we run USD GBP, this is still running on the previous version on main, where it's kind of rubbish because it tells you all about these like dirhams and Afghanis and things that I didn't ask about. I just asked for USD GBP. So if I go ahead and merge that change, we've got a pull request with an improvement in it. We've got a passing test. And then we've got the CI system runs in order to test that latest commit on main. And at the same time in the background, what we'll see is that Flux did its job. And so if I run, there we go. Yeah, we can see we just appended, we just applied this revision, this 125 revision. And that will have deployed. Let's just check that that's, yeah, the 125 revision has been deployed into production. And so what we can see, and the test passed on main, so that all looks good. So let's go back to the app in production and try it again. This might be actually sort of deployed on your website, for example. USD GBP. It works. It only shows me the USD GBP rate. Yay! Awesome. So just to recap, there's quite a lot going on in this picture. But what we just did was we created this sort of complete CI/CD for cloud-native GenAI reference architecture where we have a developer working on improving an app on this blue flow, this CI flow to begin with, where they are modifying this AI spec file that contains the model, any prompts, knowledge, the API integrations, and in particular, we were iterating on the prompting for the API integration so that it improved the behavior of the model when given a currency pair. And then we were iterating also on the tests. We were able to run those tests locally. We pushed a branch to GitHub. GitHub Actions kicked in, ran that same test in CI. All of these tests happening against the Helix cluster in test namespaces. We got this test results table. We were able to merge that pull request to main. And then once that pull request got merged to main, we could see that Flux kicked in, received the update. It received the update to the Git repository, which is here. And then the source controller applied the change to the CRD to the Kubernetes cluster. So I can also show you, for example, kubectl get AI apps. And we can see that exchange rates app is there. It was created 23 minutes ago, but it was updated more recently. And we can see, we can even see the actual prompting inside the spec for that AI app. So that AI app got upgraded. And then the Kubernetes operator kicked in. And what you can see here, it's got quite verbose logging, but you can see it's checking if the app existed in Helix. It found the matching app. It retrieved the app, and then it updated it in the Helix deployment. So this is all what we see here. Flux notices the change. The AI spec gets updated. The AI spec CRD in Kubernetes gets updated by Flux. And then the Helix operator notices that change, deploys the update to production, and then the user gets to experience an improved application, as we saw. Okay, let's take a breath and tear everything down and create this entire system from scratch so that I can show you how easy it is to set up this application or this reference architecture on your own laptop. Everything you saw today was running entirely on my own machine. For development purposes, we're using Together AI as an external LLM provider. But like I said, it's possible to run this entire stack locally on your machine. So I'll just take you through the steps. We are going to begin. I've already exported this Together API key in my environment. So we're going to start by running this script. The first thing that script does is it tears down that kind cluster that I had running. And so you'll see everything here has just like died because I just destroyed the entire Kubernetes cluster. And then and it does warn you about that. If you need to start over, just rerun the script. It will tear down the kind cluster and recreate it from scratch. Of course, bear in mind that anything you have inside your Helix deployment that you care about will also be destroyed when it tears down the entire cluster. But the good news is that the application that we care about is version controlled with GitOps. So it's trivial to redeploy it. So let's see what's going on inside this Kubernetes cluster. So the first thing that Helix does when you set it up is it sets up a Keycloak instance with a database for Keycloak. That's a user access and management server, basically. And it looks like that's starting up now. Keycloak takes a minute or so to start up. Okay, so Keycloak has started up, and now we're going to boot the Helix control plane. This also just takes a minute to boot. Okay, so everything's running. Just clear these terminals to avoid being confusing. Then we can copy paste these commands here to set up a port forward. And then we can access the browser, access Helix in the browser. The next thing we need to do is we need to sign up for an account. By default, Helix allows anyone to sign up and makes all new users admin users, which is fine in development. In production, you will want to lock it down, which is fully documented in our documentation. And so you can start by being like, is it working? And yes. So we've now got Helix running locally in kind on my laptop, configured to point to an LLM provider out on the internet. Although, as I said, you can also deploy GPUs in Kubernetes or external to Kubernetes by deploying these runners. And you can also, for example, provision them from services like RunPod, where they are nice and cheap. But for now, we're using Together AI, just because it makes everything a bit more lightweight when you're running it all locally on your machine. So let's, we've got that up and running. Let's just follow through the steps. So we loaded that. We created a new user. So for now, we also have to run the operator locally. So I've already cd'd into this directory helix/operator just because I checked out the Helix repo inside here. I'm going to run make install. Of course, we're going to package the operator any day now, so that it's included with default Helix installs out of the box. I then need to go to my account page, copy paste my authentication credentials into here, and I'll put them in here because I think I'll need them there later as well. Then I can hit, actually, I needed to paste them in there because that was the terminal I'm going to use. So I'm going to do make run inside this terminal, and that's going to start up the operator using that API key that I just provisioned. So now I can just test that this thing works. I'm not running Flux yet, so you'll see nothing is getting reconciled into the cluster yet. So I've got an empty app store, nothing in there. But I can kubectl apply this exchange rates app. And then if I hit refresh, you can see it's here. And of course, this is the version of the app that we just fixed earlier in the tutorial. So you can see it's now giving us nice answers to when I asked for USD GBP. Yeah, let's carry on setting up the reference architecture. So we've got something that looks like this. Indeed, we've got the port forward running in this terminal. We've got the operator, the Helix operator running in this terminal. And then we've just tested that we can kubectl apply. We've checked that the app is working. So now we can go ahead and delete this thing. And we can just check that the reconciliation in the cluster worked. And yes, the app is now gone. And then we can set up Flux. So this is actually really easy. You just run Flux install. That's going to install some things. If I do that, I get to see them. So that's starting up the Flux components. That's up and running nicely. I've already exported my GitHub username in my environment, but you'll need to do this because when you run through this yourself, we recommend that you fork the repo because part of the experience here is, of course, like pushing changes to the repo and noticing that that things react. But for now, I'm just running this against the Helix ML version of this repo. So I'm going to go ahead and create the Git source in Flux so that Git has a reference to the repo. And then I'm going to create this Flux customization in there. And so that will now every minute check the this repo in the AI specs folder for any changes to the YAMLs. And of course, if we look in here, we can see that YAML file there is this Kubernetes object, which is the thing that we're iterating on, because it is the AI application, the exchange rates application. So Flux should now be up and running. And indeed, we can see that, remember, we deleted that application before. Now Flux has gone and recreated it because it's made Helix match up with the state in Git. So that is literally GitOps is working. We deploy Flux and it notices, oh, the application isn't there. I need to install it in order to make the desired state in the repo match up with the actual state in the cluster. That's it. That's it for Flux. The next part is setting up GitHub Actions. So in order to make that work, we need to use ngrok, because of course I'm running this all locally, but GitHub needs access to the GitHub needs access to my to Helix running inside the kind cluster on my laptop, which is behind NAT. So we use ngrok, and I'm just going to go into GitHub and change the settings for my secrets in my GitHub Actions. So the first thing to change is the variable, which is the URL, because that changes every time you redeploy it. So that's my new variable. The other thing I need to do is change the secret, because every time you redeploy Helix and recreate a user account, then you get a new API key. So I also need to update the API key in GitHub Actions. And then we can check that CI is working by going in here and just rerunning one of the latest actions. If I go in here, I can rerun all jobs. And so what's happening here is that GitHub is reaching out through ngrok. You should see some requests show up here. It's going to reach out through ngrok and test the latest commit on the main branch. There we go. Those requests are flowing through ngrok. You can see it testing the application, evaluating the application, and then uploading the results to the Helix file store. And then we helpfully get this log message inside here saying that we can go and look at those results. And yay, all the tests are passing. So you can see that the system is now working better, and you can even see the evaluation is working, and you can see the LLM is being used as a judge to determine whether or not the tests are passing. So yeah, that's all working. We saw Flux working, we saw CI. I guess the last thing to show is that you can also run those tests locally. I think we already saw that, but just for completeness, let's run that against the deployment that we just spun up. And yes, that works. And when you run the tests locally, you can see that they do indeed pass. So yes, what we've seen today is how to set up this complete GenAI reference architecture for CI/CD for on cloud native. We saw all of these different pieces working. We saw a user, a developer, running tests against an application, finding that one of the tests was failing, fixing the test, running it locally, checking that it also passes when you run it in CI, and then merging that branch to main, merging that pull request to main with a green PR, and then seeing that Flux was able to reconcile that update to the Git repository via the AI spec CRD into the Helix operator, deployed that change to production, and then we got happy users because we were able to improve the exchange rates app that we developed. So yeah, thanks for watching. I hope you enjoyed this. If you want to set this up yourself, go to our GitHub, github.com/helixml/GenAI CI/CD ref, as in the reference architecture. I also encourage you to come and join our Discord, because I'd love to hear about whether you have a good time with this or if you run into any issues. please just scroll down to the bottom of our homepage, which is helix.ml. You can hit up the Discord button and come and join us on Discord. Thanks so much for watching. It's great to share this with everyone. Thanks. Bye.